I guess we got part 1 and part 2.
You start over?
Oh, please no.
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 Okay, so now, arithmetic, geometric.
Jump.
Geometric, right? So we have a rule. It's geometric. There's my rule, right? Let's write that down. If you use the board, the formulas, it's not too bad. So I'm going to go a of n equals a1, r to the n minus 1. We're going to keep n as a variable. So my formula is going to be a of n equals -6 times -2 to the n minus 1 power. R is my multiplier. A1 is my first term. A1 is my first term, and R is my multiplier. Do not multiply these. Do not make -6 times -12 into a 12. Don't do that. You cannot, because with the order of operations, you're supposed to take the exponent first, and you can't. So you're done. Okay. How am I doing? Number 3.
I'm confused.
Okay, good. I'm stopping.
The 192 is like negative?
No, it's positive, because it goes negative, positive, negative, positive, negative, positive, right? Okay. Number 3, I've got a 2/3, 3/4, 4/5, 5, 6, ... What's going on?
It's adding by 1.
Yeah.
1.
So I'm going to get a 6/7. I'm going to get a 7/8. I'm going to get an 8/9, a 9/10, and an 10/11. Right? You guys see the pattern? You see the pattern? Now, because this is because this is neither arithmetic nor geometric. You're not multiplying by the same thing, but there's a pattern. You see the pattern, right? So this is one of those cases where we're going to have to use our brains and think about what's going on. N is always these numbers. So the number n is always 1, 2, 3, 4, 5. So this is always 1 more. This is just 2 more than n. So my formula on this one is going to be an n plus 1 over an n plus 2. If I plug in 1, I get 2/3. If I plug in 2, I'll get 3/4. Okay, so this is the one where you're going to have to think. There's no golden formula that's up there. You just have to think about how you'd create it, okay? You can do this. I have faith in you.
Thank you.
I do. Turn the page.
Oh my.
No.
Wait.
Wait.
I'll turn that page. It's like
Okay, turn my page.
Alright, cool.
Lauren, give me a thumbs up when you're ready.
Alrighty.
Okay. All right. Number 4. I've got a 12 plus 14 plus 16 plus 18 plus 20 plus all the way to 130. Okay. Now, it says summation, right? Summation. Boom. There it is. Right? So let's write it down. Let's go straight to sigma n equals 1. Okay, now we need a formula, right? So is it arithmetic or geometric? Arithmetic or geometric?
Arithmetic.
Yeah, so let's use that one, right? Let's use that one. So it is arithmetic, so we'll go, okay, a1 plus n minus 1 times d. We're going to keep n as a variable, right? Okay, so I'm going to fill some things in. N equals 1 of a 12 plus a n minus 1. And what's the difference? 2. Okay. I'm going to simplify this. If you don't, I wouldn't mark it wrong, but it's easier for me to work with it if I do, okay? That is a 2, yeah. Yeah, because the difference is, right, up 2, right? Yeah. 12 plus a 2n minus 2, or n equals 1 of 2n plus 10. Okay, so far so good, right? Now, what's going to go up here? Well, something's got to go up there. Something's got to go up there. There you go. So this formula has to create 130. What n will do that? Well, let's set this formula equal to the last term. We'll find out what n created it. Okay, so 2n plus 10 has to make 130, right? If I solve for n, I'll know exactly which n to plug in, right? Okay, so let's do that. Let's go, all right, minus 10, divide by 2, n is 60. So there's 60 terms. Thank goodness I'm not going to make it. Thank goodness I've got a formula, right? So 60 goes right there, okay? Boom, that's my answer. 5, does that seem pretty easy?
Wait.
I'll write 5 down, Ben, while I'm waiting for you, okay? 2 plus 10 plus 50 plus 250 plus 1250 plus 781,250. Okay, you ready?
No.
I'll wait for you. Okay, I'll wait for you. So it says summation, right? It says summation. Let's write the sigma. N equals 1. And now, is it arithmetic or geometric? Is it geometric, isn't it? Because I'm multiplying by 5, right? So I'm going to use my A1 R to the n minus 1 power, right? Or let's rewrite this. N equals 1 of 2 times a 5 to the n minus 1 power. You okay with that? Don't multiply those two. Don't make that a 10. Do not make that a 10. Don't do that. Don't do that. Now, what goes up here? Well, there's two ways to do this. I'm actually going to do it the long way, because otherwise we'd have to do logarithms. We can set this equal to this, and we could do logarithms to solve for n. We could. Or we could just create the terms in between. In fact, let's create the terms in between, okay? All right.
I don't think it'll be that many.
I don't think so either. So you ready? Help me out. Okay. Krush, what's 1250 times 5? 1250 times 5, what do you get?
6,250.
Okay. Times that by 5.
21,250.
Okay, times that by 5.
It's 31.
31. Okay, got it. Times that by 5.
There. Gotta be.
Okay, 156250. I don't know what else.
Multiply that by 5, and I think you get this one. Okay, so,
You do.
Nikolai,
7, 8.
how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 terms.
Well, how did you get that?
How did I get this? Well, you weren't paying attention. We were multiplying by 5.
Yeah, but where'd the 5 come from? Oh, wait.
Okay, that's my answer, right? How did I get the 9? There are 9 terms, aren't there?
Yes.
Yeah.
That's federal.
How is supposed to know that it's
Wait, don't take down this.
Or you could solve it and do logarithms, which I can show you later, okay? Okay? Because we know logarithms, don't we? We do know. Okay, gone. All right, here we go. Don't go home yet. Okay, what do we got? Number 6. 6 is the easiest of all. Seriously.
Good.
Yeah, you're ahead of me. Good, smart girl. Smart girl. That actually is going to come in handy. Plus ... Okay, so summation, right? It says summation, so go. Boom. N equals 1. Now, Katie, what goes up here, smart girl? You guys agree?
Did you mean to write plus 25 twice?
No.
Nope.
okay.
Nope. Okay, one more time. Katie, what goes right up here? You guys agree with Katie? The ... So you don't have to find out how many terms there are, because you know there's an infinite. Okay. Is it arithmetic or geometric?
Geometric.
Yep. A1 R to the n minus 1 power. That's my formula. Yeah, Cody?
Do you always have to write n equals 1 underneath it?
Usually. There's times we do something different, but we're going to keep it easy, okay? So in here, yes. Yes, okay? Because we always want to start with the first term. Does that make sense?
Yeah.
To make the first term, we plug in 1, right? Okay, now let's go n equals 1 to infinity of 400. What's my multiplier? What's my multiplier?
A 1.
What's my multiplier? What am I doing? Boom, boom, boom. What am I doing? Boom, boom, boom. How am I making these?
Dividing by
Dividing by 4 or multiplying by 1/4. Isn't that the same thing? There's my formula. Okay.
Is that it?
No, Cody, you're going to an A. Okay. All right, you ready for 7? So look at 7. Arithmetic, geometric. Which one is it?
I don't know.
Geometric.
It is, because I'm multiplying by 2, aren't I?
Right.
So it is geometric. So if I need the rule, I'm going to go an equals a1 times r to the n minus 1 power, right? I need a rule. So we're going to go an equals, what's the first term? What's the value of the first term?
1/4.
I think it's 1/2, because these go by 2s, right? Because this goes by 2, right?
Yeah.
Okay, and then you know you're doubling each time, right? So Cooper, right here, the value is 2. That's got to be 1. That's got to be 1/2. What's my multiplier? It's 2 to the n minus 1 power. There's my formula right there for that geometric graph. First term is 1/2.
Okay.
Okay. Number B, arithmetic or geometric?
Arithmetic.
It is. What am I doing each time?
Adding a 2.
Yes. Ben, you're right. So if it's arithmetic, let's write a rule. A of n equals a1 n minus 1 times d. That's my rule, right? Keep n as a variable. What's my first term? What's my first term?
1.
Right? N minus 1. What's the difference? What am I going up by each time? By what? 2s, aren't I?
Yeah.
Okay, that is an acceptable answer. I like this better. I like a 2n minus 1 better. Okay, I just simplified it. That's all I did. Okay, thumbs up. All right. Number 8, we already did number 8. It's right there. We did number 8. It's right there. So to save time, I don't need to do number 8. I'll just throw it up there. We did number 8, right?
Which one of those is
Number 8 is right here. That's number 8. Okay. There, it's on film. So if you want to go back, you can see number 8. We already did in our warm-up, right? Number 8 is number 2 on the warm-up. Yes.
Can we go over it again?
No, I already did once. Okay, number 9. Turn the page, okay? Right, number 9. I have the sum n equals 1 to 30 of 5n minus 2. Okay, what this says is plug in 1, plug in 2, plug in 3, plug in, plug, all the way until you plug in 30. You have 30 answers, add them all up. You can do it that way. Why not just use a formula, okay? So once again, is it arithmetic or geometric? It's arithmetic, but if you're not sure, you can make a few terms, right? If you're not sure, if you're not, I don't know what it is, but let's make sure. So plug in 1. If I plug in 1, I get 3. If I plug in 2, I get 10. Minus 2 is 8. If I plug in 3, I get 15 minus 2 is 13. Looks to me like I'm going up by 5s, doesn't it?
Sure does.
Okay, it is arithmetic, which means I've got a formula. But if I want to find the sum, I've got to have a sum formula. Arithmetic, S of n. Arithmetic, S of n means sum, right? How many terms are there?
30.
So I'm going to go S of n equals n, a1 plus an divided by 2, right? Now, we know there's 30 terms. So it's S of 30, because we need the sum of the first 30 terms, right? We know n is 30, because there's the number of terms is 30. A1, what's my first term? I know, I just made it, right? A1's 3. What's my last term? Well, my last term would be A30, wouldn't it? I don't know what that is, but I'll find out real quick. What's a 30? 5 times 30 minus 2, 150 minus 2, 148, right? So I'll put 148 here, divided by 2. I'll use my calculator. I'll use yours. Go ahead, you just do it for me. S of 30 equals, we're just going to tell me. Did you get it?
S 30 would be.
I got it.
Okay.
I got it. Okay, well, I should have my own. 30 times 3 plus 148 divided by 2. I get an answer of 2,265. Okay?
Yes.
Right? We'll just share.
It's just confusing.
Okay, thumbs up on how I did that one?
Sure.
Okay.
Yeah.
Okay. No. Okay, I'm going to turn my page. Okay. Number 10. Okay, number 10. We've got the sum n equals 1 to 10 of 18 times negative 2 to the n minus 1 power. Now, it's sum, right? Is it arithmetic or geometric? Arithmetic or geometric?
Geometric.
Sure looks like it doesn't because it fits this pattern, doesn't it? Right? You guys agree?
Yep.
So A1's got to be what?
18.
And the multiplier R is what?
Negative
But we
2.
want the sum, so we're going to use that formula.
Right. Right.
See how it works? So I know A1 is 18, right? I know N is 10 because there's going to be 10 terms. I know the multiplier R is negative 2. So my form is S of N equals A1 1 minus R to the N power divided by 1 minus R. So let's just plug the numbers in and carefully plug it into our calculator, okay?
Is that S or 5?
It's an S.
Yeah, it's an S because we're doing the sum. Does that make sense, Lauren? So I'm going to go S of 10. That's what I really want to find. It's first sum, first term. A1 is 18. 1 minus R, which is a negative 2 to the 10th power, divided by 1 minus a negative 2. Now, you got to be really careful on parentheses in your calculator, okay? I will show you on my calculator, okay? So on my calculator, I'll put it in and just watch how I do it. Okay, I'm going to go 18 parentheses 1 minus parentheses negative 2 to the 10th power. Parentheses divided by parentheses 1, subtract a negative 2, parentheses. It's a booger to put in, but grand answer of negative 6,138. Now, if you have a difficult time putting the calculator, just do step by step by step, write it down as you go. Does that make sense? Okay. So I got an answer of negative 6,138. Okay. How am I doing?
So great.
Okay.
So great.
11. I'm getting there. I'm getting there. 11. All right, 11 something new. And I meant to have you guys learn it this last week, but I don't know if Ted showed it or not. Okay? But anyway. Okay. So, this is number 11, yeah. Now, there are two ways to do this one, okay? I'm going to use a formula because it's faster, okay? The long way. You guys want to see the long way?
Nope. No,
Check it
no,
out.
No.
You're going to go 1 squared plus 1. Then you're going to go 2 squared plus 2. 3 squared plus 3. 4 squared plus 4. 5 squared plus 5. 6 squared
not
plus
even
6.
that.
7 squared plus 7. That's all I'm doing,
I
right?
hate to break it to you, that is not the long way.
Oh, my form is so much faster.
No way the formula is going to
Okay.
take less time to explain to us than that.
Now, what's a better way? I like the formula, okay? So there is an n squared formula. There it is right there. My n squared formula is going to be n squared is equal to n times n plus 1 times 2n plus 1 divided by 6.
Wait, Mr. Davies, this is going to be on our test.
Yeah, but it's super easy.
But we didn't even practice this one day of the week.
Well, it's easy. Plus n, which is n times n plus 1 divided by 2. This is my n squared formula.
This is long.
What's n? N is 7.
Like this formula.
N is 7. There's 7 terms, right?
I also would like this.
Oh my goodness, watch how easy this is.
Formula is
7 times 7 plus 1 times 2 times 7 plus 1 divided by 6 plus 7 times 7 plus 1 divided by 2. I'm just plugging 7 in.
You just said that in my part. 1.378. See, now you're going to have to explain that to me, and it will take way longer.
You sound like Miss G right now. It's kind of.
I'm sorry.
You
So,
should be. That's the worst thing you could be called.
I'm sorry.
That is,
You guys are on
that
tape
is
though. Come on now.
definitely
This is
not-
going to go public. This is going to go public. Let's be kind. Okay.
I don't.
All right, what's 7 times 8 times 15 divided by 6? That is 140 plus
Mr. Davies, you need an editor.
28. I need an editor?
Yeah, to crop some things out of the video.
Yeah. Yeah.
To crop out some voices.
Okay, so how this works is, really, if you had to go and do, say, 1 squared, 2 squared, 3 squared, 4 squared, all the way to 100 squared, it'd be a pain. If you plugged in the numbers into the formula, it gets you the answer pretty quickly.
There's no way that's easy.
I think we should skip 12.
That's gonna be on the board, right?
12 is the same as 11.
12's so easy.
So let's skip 12.
12's not the same as 11.
It's easy though, let's skip it.
Nope, I'm going to do 12. Okay, here we go. Here comes 12.
Say it.
Okay,
I don't like that.
Shamak.
okay, now, you cannot add to infinity unless it's getting smaller. Shh, Ben. You can't add to infinity unless it's getting smaller and smaller and smaller and smaller. So that the last piece you add is nothing. Does that make sense? That makes sense, right? Fortunately, we have a formula to add to infinity. S of infinity. It's right there. See it? So let's write that down. We're going to go S of infinity. A1 over 1 minus R. Well, A1, what's the first term? Good. It is 100. You guys agree?
Right.
What's my multiplier? What's R?
1/5.
1/5. And to make it easier for you, let's make it a decimal. Does that help by making it a decimal? Makes it easier for you. Okay. So let's just plug it in. S of infinity is equal to 100 divided by 1 minus 0.2. 125.
Wait,
Yeah.
That's one of the easiest questions on the test.
wait, so infinity equals 125.
Right, because what you do, Ben, is you're taking a fifth of 100. So, Ben, let's start with 100. So, what we do is we take 100, then we add a fifth of it, then we add a fifth of that, then we add a fifth of that, and we're adding smaller and smaller and smaller pieces. So the very last, we're going to add them all up, so we know for sure the answer is already 124.
Wait, but there would really be no end, but like that's
But if you could
hard.
go to infinity, right? Do you remember, I don't know, I wasn't here, but do you remember the activity with the square,
Yes,
right? And you know the answer is 1, right?
right.
So if you cut in half, 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 we know the answer is 1, right? If you add all these pieces to infinity, you know the answer is 1, right?
Whoever developed that was definitely weird.
Every mathematician is weird. Okay, I'll just leave it there, okay? All right, moving on. That was pretty easy, wasn't it? Moving on.
Yeah.
Okay, number 13. Here comes that darn recursive stuff, okay? Okay.
Is geometric,
Yes.
and it would be
So,
-3.
good. So when you do recursive, listen, shh, recursive, you absolutely have to say what A1 is. Most important thing, if you're going to do recursive, you've got to say where you're going to start. Cooper? No. Colby? No. So, Cody, what's my first term?
-1.
What am I doing each time? A to the n minus 1. So I'm going to take my previous term, and what am I doing to make the next one? I take my,
By -3.
I'm times it by -3. That is my formula. I need both, though. That's it. That's it. Okay, 14.
Just write the formula?
Yeah. Okay, so when you do recursive, first step, always tell me A1. What's my first term?
A1.
What am I doing every time I go A to the n is equal to, take the previous term,
We're done.
and what am I doing?
You go up.
What am I doing each time?
You're subtracting a.
That's it. You need both. You need to know where to start and then tell me what's going on. You start at -1 and then take your previous term, subtract 8. Take your previous term, subtract 8. Take your previous term, subtract 8, right? Now 15. Let me go ahead. Yeah. So to do 15, is it arithmetic or geometric? I don't know, but let's make a few terms, okay? So if I plug in 1, what do you get? A1. If I plug in 1, what do I get? 11. If I plug in 2, what am I going to get? 17. If I plug in 3, what do I get? 23. What's going on each time? Good. So if you're going to do a recursive formula, correct. If you do a recursive formula, you always start with A1. A1 equals what?
11.
What am I doing each time?
Adding 6.
So I'm going to go A to the n minus 1, and I'm adding 6, aren't I? So the advantage to the recursive form is it tells you what's going on, correct? It's not very useful because it doesn't help you get anywhere. Like if I want the 100th term, I'd have to make all 100 terms or have a better formula, which are up there. Okay. 16.
Okay.
That's the easy.
Okay, 16. Let's do 16. All right, 16. I've got A1 equals 48 and R equals 2/3. Okay, so what would be going on? If I made this formula, what would I do every time? That's 2/3. Right. So my formula is A1 is 48. A to the n is equal to, take your previous term, A to the n minus 1, A to the n minus 1, and I'm going to multiply by 2/3. That's it. This always means take your previous term, do something to it. Take your previous term, do something to it, right? All right, 17, last but not least.
2 questions to this one. You can't say
Okay,
less.
17, all right? So, I'm going to take $300 in the bank, and what I'm going to do is add 40 years each time. So then I'm going to add 40, okay? So is this arithmetic or geometric?
Arithmetic.
Good, it is arithmetic. So let's see, we got a formula. A of n equals A1 plus n minus 1 times D. You guys agree with that? It is arithmetic, right? So I'm going to have let's see, what do I need? I need the 20th year, right? I need A of 20 equals, let's see, 300 plus 20 minus 1 times 40. You okay with that?
Sure.
Okay, so then, I don't know, calculator time. Let's see what that is. I've got clear. I've got 300 plus 11 times 40. I get an answer of 740, okay? So the 20th year, I'm going to put in $740, right? But I already got money in the bank, right? How much total? Well, that's a sum. That's a sum, right? So I'm going to have 300 plus 340 plus 380 plus, right? So I'm going to use my S of 20, which is this one, right? Use that one. I'm going to use my N times my A1 plus my AN divided by 2. There's 20 terms, right? S of 20 equals 20. What's my first term? 300. Right? That's my first deposit. What's my last deposit? 740 divided by 2. Use a calculator. I don't know. 20. Yeah. 20 times 300 plus 740 divided by 2, and I get an answer of
Supposed to look like that. Like it's supposed to be small.
No.
and I am done.